So today we're going to just continue doing a couple more examples. We're not throwing out any new concepts. We're just getting more practice to get you more comfortable before we move on to some new concepts. So what we have here, we have another proof, of course, and notice what the given is saying. It says something about a midpoint, which that's been a pretty popular word for some time now. So we know H is the midpoint of segment GI. So no labeling just yet, but I know you know what we're doing here. And then we know segment JH is congruent to segment HI. So I'm going to go ahead and label that in the picture.
Lovely.
All right, I'm going to start writing the given, and keep in mind where we're going, Mrs. Hochgravy.
Okay, well, I'm seeing the midpoint, and you're right. When I hear midpoint, we know the definition of a midpoint is that it forms two congruent segments. It's splitting a segment into two congruent segments. So just by looking at this, I know that because H is the midpoint of GI, that GH and HI, sorry, I'll let you get there.
You're fine. So segment GH
is congruent to segment HI.
And what's the reason for that?
That is the definition of a midpoint, is that it's forming those two congruent segments.
Handwriting's a little sloppy. Sorry, guys. All right, so I could probably go to the picture and maybe label that.
I think that'd be a great idea. And since we've already labeled the HI with one tick mark, let's go ahead and do GH with just the one tick mark too.
Good idea.
Okay, so now I know that GH and HI are congruent. I know that JH and HI were congruent. I need to get to JH and GH congruent. Well, that makes sense. They're both congruent to the same thing.
Okay.
So because they're both congruent to HI, they must be congruent to each other. That's that transitive property.
Yeah, so what she's noticing, these two segments here, notice they're congruent to the exact same segment. Since segment GH is congruent to HI and JH is congruent to HI, we can go ahead and say...
And I'm looking at how I'm supposed to prove it. So I'm going to say JH first is congruent to GH. Now here I have to say transitive because I know it's not an equation, so I can't use substitution.
Yep. So before, a lot of times we'd say transitive or substitution. But again, what Ms. Hochgravy says is perfect. Since we're dealing with congruence, that transitive property kind of works both ways in a sense.
Right. And substitution is only for
equations. And that's where we wanted to go.
So that's it.
So that's
easy proof.
3 steps. Love it.
Love it.
All right. Let's try another.
Okay. On this one, notice what we're given. Here we're given that RS and XY are congruent. So RS and XY are congruent.
Are they congruent or equal?
Sorry, they're equal. Thanks for catching me. We were just talking congruence on that last one, so it's just stuck in my brain. Sorry. Thank you again, Mrs. Palermo. RS is equal in measure to XY, and that ST is equal in measure to WX. Now, they're equal to each other, which does mean that they are going to be congruent. So we're going to mark them with the tick marks, but do I want to put one tick mark with each of these?
I would say 2 because we can't say that they're equal to the other ones.
Exactly. They are equal to each other, but not to the other segments that we've marked. Okay. Look at what we're trying to prove on this one. We want to prove that RT is equal in measure to WY. Now, looking at that, it should be kind of a no-brainer. Again, these proofs that we're asking of you are not necessarily far stretches for us, for our imaginations to go. We just need to think about the step-by-step process that'll get us there. So I'm going to go ahead and start writing, and Ms. Palermo, I'm going to let you start thinking.
Okay. Well, and like Mrs. Hochgravy was saying, it's, I look at it and I'm like, well, RT is made up of a 1 and a 2 tick mark, and WY is made up of a 1 and a 2 tick mark. So it makes sense that those are going to be equal. But again, we need to fill in the gaps. We need to think about our logical argument. We don't want anything missing. And all we have right now to work with is just the given that's written down. So I'm noticing there's really not much I can do with the given right now unless I wanted to convert everything to congruence, and I don't see a point to that yet, maybe. I don't know, maybe, but since we're going with equality, and then we might just stay with equality. We'll see.
Yeah, and we're trying to get to equality in our final
So we may
answer.
not. Okay, so I know since the given doesn't say much more, I'm going to look at the picture, and the fact is I need to state something about RT.
Right.
And all I know about RT is from the picture is that it's made up of RS and ST. So I can add those together, right?
Absolutely.
So I'll do RS plus ST is equal to RT. And that's my segment addition postulate again. And again, the reason why I'm saying that is because I need to say something about RT. I need to establish that because that's where we're going. And the given does not say anything about it. Right? I got to also say something about WY, so I'm going to do something similar and say WX plus XY is equal to WY. And same reason, don't depend on each other, so in the same step.
Sounds great. Okay, so now we haven't used our given information yet.
Yeah. We've only said stuff in the picture. The given, I could probably do some maybe replacing of some of that stuff.
Okay.
Okay. Here's what my thoughts are. I'm thinking I want to somehow show RT and WY are equal. And when I look at the statement right now, they equal not the same sum. I mean, RS plus ST and WX plus XY don't look the same. So I need to somehow make them look the same. So what if I put XY in for RS?
Okay.
And WX in for ST. Now I could interchange those. This is what I'm
right.
thinking.
So you could have put the RS in place of this XY
Yeah.
and the ST in place. That's what you're saying. They're interchangeable.
Yeah.
Sure. Okay, so let's do that substitution here.
So that would look like XY plus WX equals RT.
And what's your reason that you
Substitute.
did that? Okay. Now, take a look, because we've used this step now.
And we've used the
and
given.
we've used the given. We haven't used this step yet.
And I'm looking and I'm noticing that RT and WY have the exact same sum.
They both, because they both have the XY
and the WX. And it doesn't matter, like, with addition.
Yeah, order doesn't matter with addition.
So they have the same exact sum, so I can just set them equal to each other.
Okay. Does it matter which one we start with?
Let me look at the proof. Yes, let's start with RT. So RT equals WY. And I'm thinking a couple different things. Since both RT and WY both equal the same exact thing, I could probably say transitive, because transitive, again, is that equality or congruence. But I'm also thinking I could substitute. I could replace the RT in for that sum of WX plus XY. So substitution also. So I didn't have to change anything to congruence.
Didn't have to on this one, because this one is really just all dealing with equality. But it is important to know, though, that we do have, when we have these segment addition postulates, that you do have to make sure everything is in equality to be able to substitute stuff in.